Okay, 3, section 1. This is Algebra 1, functions. So if I put something like this up on the board, these are what? Coordinates. Okay, they've got an x value, they've got a y value. All right, so a lot of the stuff all of the stuff that we deal with functions is going to deal with x's and y's. By themselves, they're coordinates. Together, they are called a relation. Okay, I'm relating more than one coordinate to another. Okay, so maybe we put that on a coordinate plane and it's a line. Maybe it's a triangle. Maybe it's just 3 random points on a coordinate plane. Whatever it is, they are a relation. And they have 2 different values. They have the x values, and you can circle or underline however you want to do it. And they have y values. Obviously different if we were to put them on a graph. Okay, and in a relation, these have very specific names. The x values are called domain. So if they ask you what the domain is, they're asking you what are the x values of that relation. So the y values, good grief, all kinds of crazy here. Live recording, it is what it is. Okay, so the y values are called the range. Okay, home on the range, where the deer and the antelope play. Okay, so the easiest way to remember that, x and y are alphabetical order. X comes before y. Domain and range are alphabetical order. Domain comes before range. D comes before R. All right, so if they're asking you what the domain and range are, they are looking for x and y values. So let's take those coordinates. What's the domain? If I asked you to tell me the domain of that relation, what would it be? 3, 4, and negative 4, to your knowledge, right? Okay, so when we write domain, okay, the domain values are 3, 4, and negative 4. But when we write it in what's called set notation. And that's just a squiggly little parenthesis. Okay, it's like a parenthesis with a nose on it. All right? And we write them in order from least to greatest. So the actual domain of this relation is going to be negative 4, 3, and 4. I know there's somebody sitting in their desk going right now, do they have to be in order? Yes. If they are not in order, they will be counted incorrect. So let's look at the range. The actual values are negative 2, 1, and 6. And so we do our little set notation, our little parenthesis with a nose on it. And in this case, they're actually in order. Again, they would go in order from least to greatest. That's going to be negative 2, 1, and 6. Oop, not a very big nose on that one. Oh well. Okay, you don't have to get too creative. If you just want to put them in parentheses, I'm not going to count them wrong. All right, if you want to have some fun with it and try to put a little nose on your parentheses, that's cool too. Okay, so domain and range listed in order from least to greatest. Never repeat a domain or range value. So let's say if I added negative 4, negative 2 to this. Okay, negative 4 is already in my domain range. I don't put it there again. Negative 2 is in my range. I don't put it again. I list each number only one time. Okay. So now we're going to graph. You guys can sketch this on your paper, is fine. I'm going to show you 2 different ways to tell if something is a function or not. Is that a relation? Did I just graph a relation? We have to know what a relation is, right? We just talked about it a couple of minutes ago. What's a relation? It's just a collection of what? A collection of coordinates, a collection of domain and ranges. They're just coordinates, right? Is this a collection of coordinates? So is this a relation? Absolutely. Okay, so what we're going to do here is we're going to determine if this is a function or not. If you NCTI. Okay, is this a function? To determine that, we're going to do what's called the vertical line test. So what are you going to need? If we're going to do a vertical line test, what are you going to need? A vertical line. Okay, ruler, pencil, your index finger, the side of your calculator, whatever you want to use as a vertical line. I'm actually going to put just a vertical line up here because that's easier for me. And here's what you do. You take that vertical line and you move it over until it intersects your relation. How many intersection points are there? It's only one, right? So I go over until it intersects again. How many intersection points? Still just one. So I go and I keep going. How many? One. And how many? One. If it intersects your graph only one time, each time, it is a function. So this is a function. Again, this is the first method I'm going to show you. There's actually two methods. Some of you will like this one because you're more visual. Some of you will like the other one because it's a little more logical. Okay. So let me show you one using this method that's not a function. Okay. Anybody see it already? If I move this over, how many intersection points? 2. Makes it not a function automatically. If it hits it 2 times in your vertical line test, 2 or more, could be 3, depending on what kind of crazy drawing they give you. All right, maybe they just put all of these coordinates right there. And when you do your vertical line test, it hits it 5 times. Guess what? Not a function. Okay? So if it intersects 2 or more times, okay, intersects 2 or more times, it is not a function. Good grief. Board's going crazy today. Yeah, it's crazy. Intersects 2 or more times, it is not a function. So what's the other way, Mr. No? I don't like to graph. I don't like to be visual, so I want to do the logical way. If I have a set of coordinates or a relation, would you all agree that I could put those coordinates on a graph and I could do my vertical line test? Pretty simple, right? Just take a little bit more time. Got to put them all on there. Okay, here's the other way. Identify your x values. Highlight them, circle them, underline them, whatever you want to do. Doesn't matter to me. If they are all different, it's a function every time. So are these all different? Yes. Yes. All right. So if all x values are different, It's a function. Now, some of you are like, well, that's the easier way, I think, of the two. I would agree. Okay, I think it's the easier of the two. But sometimes there are some things that might trick us just a little bit. For example, what's the first thing I told you to do? Highlight the x values, right? Or circle them or underline them or whatever. As I look around, I see people not writing this down. I'm curious why. I see a lot of pencils down and people not writing. I'm not sure why. What was the rule? If all the x values are different, it's a function. Okay, now I'm going to ask you this question. Is this a function? Okay, how many of you say yes? Raise your hand. Yes, it's a function. How many of you say no? Gotcha. Okay, this is the tricky part.
It is a function.
It is a function.
Because, can I say?
Why?
Because 4 negatives, there's 2 4. So 2 negative 6.
They're the exact same point.
Same thing.
So if I put this on a graph, I literally would graph these 2 points on top of each other. So they're actually just 1 point. So that's the danger in, hey, it looks easier because just those are all different, or those aren't all different. It's got to not be a function. All right, but be careful. If you graph this, nobody would have missed it. Everybody would have said, yep, it's a function, because vertical line test, you would have graphed the same point on top of each other. Be careful. All right, so in this case, in yellow, this is a function because 4, negative 6 is the exact same point. It's not different. So here's one that is different. Let me show you. Okay, so in that case, 4 does repeat itself, and both of those numbers are different. So is this a function, yes or no? This is not a function. Okay, so be careful if that's the method you're going to use. If you're going to use the graphing method, it'll work itself out and it'll be easy. Okay, be very careful. All right. Without doing a graph, what if I gave you that? That's called a parabola. Function or not a function? Function. Okay. What if, let's see, this is, I want to write that down there. This one is a function. What if I tilt it a little bit? How many of you think this is still a function? Raise your hand. Yes? Okay. How many of you think no? All right. Let's do the vertical line test. What's it got to do? It's got to intersect twice somewhere on the graph. Boom. Twice. Not a function. Okay. So sometimes it depends on how is the shape facing. Okay. Circle obviously doesn't matter because a circle, regardless of where you put it, is a circle. Okay. It's always going to not be a function. All right. Now, final thing. Let's see, how do I want to do this? I want to do that same parabola. Nope. I forgot a part. Hello. Okay, that's what I want. What's the domain and range of that function? Okay, so let's hold on a minute. Let's go back and rewind. Domain is what values? The x values. Okay, so just quick little review here. And the range is the y values. When they gave us the coordinates, it was easy to pick the x and y values off of there. When they give us this, well, what's that y value right there? Because it's in between a box. Ugh, I'm not sure. Anybody have a thought? What do you think? Jeremy, thought? Okay. He left his thought. Taya? Why would you say negative 3? Okay, so you're looking to where it crosses the x-axis. Does this have an x value down here? It better. It's on a coordinate plane. Everything has an x and y value, right? Does that have an x value up there? Sure does. Does that have an x value over there? Okay, so her thought process is good. She picks where it crosses the x-axis, but there's more. Okay? How far to the left does our x value go? As far left as we can go. How far is it? Negative 2. Negative 2 is right here. How about negative 3? This coordinate right here has an x value of negative 3. Would you agree? Its actual coordinate is negative 3, 7. All right, so if I were to write that out, this is actually negative 3, 7. Okay, so I've gone to as far left as I can. Let's go as far right as I can. What's my far right x value? 2, positive 2, right? And this is actually 2, 7. So my x values go somewhere from negative 3 to 2. Inequalities, chapter 2 that we just finished. How can I represent an x value that goes from negative 3 to positive 2? With an inequality. So something's going to be greater than and something's going to be less than. It's greater than what? Negative 3. It's greater than negative 3 because it goes to the right. Could it be equal to negative 3? Yes. So I have an x value. Here's my domain. I have an x value in the middle that's greater than or equal to negative 3. And what is it on the right-hand side? Is it greater than or equal to 2, or is it less than or equal to 2? It's less than or equal to 2. So we just created a compound inequality showing that my x values are somewhere between negative 3 and 2. All right? So now let's look at the range values. Let's look at the vertical axis. What is as high as it goes? 7. What's as low as it goes? Negative 4. How do I write that as an inequality? Be careful this time because it's y values. Okay? It's greater than or equal to what? Negative 4. And it's less than or equal to what? 7. So if you have a curve, okay, where you don't have specific points, you're going to have to use inequalities. And I believe that's the last 2 questions on the work today. Questions number 15 and 16. All right, that's a good one. About 20 minutes worth. Woohoo! Functions, chapter 3, section 1.